tenemos aquí al maestro Francisco Bersain, Moreno, de séptimo semestre, a punto de graduarse. Entonces, bueno, vamos a oír su proyecto, que es bastante interesante, el cual tiene que ver con temas muy cercanos a varios de ustedes, tanto desde el punto de vista de síntesis como de aplicaciones biomédicas.
Well, good afternoon. As it was suggested by our coordinators, I will try to give you this presentation in English. So, the research project that we are working in is a controlled biosynthesis of functional nanomaterials by natural extracts in biomedical applications. My internal supervising professor is Dr. José Luis Herrera Pérez, and my external supervising professor is Dr. Odilon Vázquez Cuchillo. Well, I will try to explain the introduction of this work, then the objectives, next methodology, results, and conclusions at the end. Well, the general objective of this work is to synthesize biogenic and biocompatible metallic nanoparticles by using plant extracts to its potential use in biomedical applications. The specific objectives that we have is determining the agave species extracts with higher potential to be used in the metallic nanoparticles synthesis, setting out the synthesis conditions to obtain these metallic nanoparticles by biotechnological routes to produce a structurally stable material with a fine chemical composition at low temperature, performing the nanostructural characterization of the different synthesized nanoparticles, evaluating by in vitro experiments the potential biomedical application of the synthesized nanoparticles. Well, as I have presented in previous seminars, the main thing that we are using in this project are plant extracts. With these extracts, we try to make a green synthesis in order to obtain the bio-nanoparticles. Agave is the main important thing in this work that we are doing. We use the agave leaves in order to produce 4 different extracts. We call them FX1, FX2, FX3, and FX4. Each of these extracts are different because we use different solvents to obtain each one of them. The FX1 fraction is aqueous, the FX2 is ethanolic, the FX3 fraction is hexanic, and the FX4 is ethanolic but selective. With these plant extracts, we reduce the gold ions in a tetrachloroauric acid solution. In this step, it's called bioreduction, when the ions got electrons in order to be reduced and then change the solution, the color of the solution. In the second step, we have the nanoparticles formation. And after that, it happens the agglomeration of these nanoparticles, causing the growing of these nanoparticles, and in the end, we have the biostabilization of these nanoparticles. With this methodology, we have obtained many nanomaterials. I have shown in previous seminar the characterization of 4 materials that we follow by spectrophotometry, ultraviolet, visible, and by transmission electron microscopy. This is the material FX1, FX2. Here we can see the morphology and the size of the materials that we have synthesized. FX3 with the hexane fraction. Here it's more controlled the biosynthesis, and we only have 2 sizes. FX4, in this synthesis, we have many spherical nanoparticles. And here is the general summary that we have of this work that we have done in the past years. So, as you can see, the gold ions are reduced, but agave biomolecules And then, as we use different fractions of the extract, we obtain different materials that has different characteristics. We found interesting to use these materials in order to be joined to another material that is very interesting in biomedical application, as is graphene oxide. Our doctoral fellow, Josemir, is working with this material, and we try to make a decoration of his material that he is working, of this graphene oxide. Here is the scanning electron micrograph of the material that he uses. And this material is also interesting to us because it is used in drug delivery systems, in gene delivery systems, in tissue engineering, imaging techniques, and in photodynamic therapies. So the methodology that we followed, we tried to make it simple because we are working with green chemistry, so as it's easier, it's best for us. In the aqueous solution of tetrachloric acid, we submerge the graphene oxide electrode in order to try to make an in situ implantation of the nanoparticles, and the gold nanoparticles. And we use a low temperature. We are using 65 centigrades. And then this material was sent to characterization. So the first thing we made, only to try to see the properties of the material, was to apply the bio-gold nanoparticles on a silicon plate in order to make atomic force microscopy, just to see the roughness profile that this gives to us. And in this characterization, we can see that we have the roughness profile of 76 nanometers. This was only to check how was the material before we apply to the graphene oxide. After we make the procedure, we send this material to scanning electron microscopy. We can see the micrograph that is showing us many little points that are the nanoparticles that we are using. I will be showing the magnification of this same material. Here is at 5,000 magnification, the same. Here is at 10,000 magnification. We can see the morphology of these nanostructures. They are similar like nano-origins. And in the right, we have the higher magnification. It is 5,000 magnification. It was the first thing we made. Here is the comparison between the material before and after the gold decoration we made. Another comparison between before and after the decoration of gold, but it is a higher magnification, 5,000. Then we repeat the procedure, but making it in 15 degrees higher, in order to see how this was going to change the implantation of gold. We saw in this micrograph that there were less particles in the material. Here is the same electrode with a higher magnification. Again, here is the highest magnification, 5,000, 50,000 magnified, and we can see the morphology of these structures. They are bigger than what we was getting before in the colloidal state. Here is the comparison between the implantation or decoration of gold at 65 degrees and at 80 degrees. We also used another extract. This is with FX2, that it is ethanolic. We see that distribution is better. We can see many of these nanogold structures that are in the graphene oxide. Here is another at higher magnification, and 2000, 5000. Again, here we can see the structures better. 10,000 magnified, 20,000 and 50,000. Here is a comparison with this extract before the implantation and after the gold decoration in the material. Here is the general resume of the summary of the procedure we made. Here is the material in A without any treatment. In B is with FX1 extract at 65 degrees. C, FX1 extract at 80 degrees. And D with the extract FX2. So we can see that it is important that the kind of extract matters, and also the temperature that you use in the process. Well, as conclusion of this work, we have seen that the agave extracts employed in this bio-gold nanoparticles biosynthesis works to reduce and also to decorate by forming gold nanostructures in situ on the graphene oxide surface. Also, the analyzed scanning electron microscopy micrographs show us evidence of the performed decoration at different image magnifications. The analyzed scanning electron microscopy micrographs show gold structures that are similar to nanoworkings, being also probably formed by the agglomeration of groups of smaller spherical bio-gold nanoparticles. The analyzed scanning electron microscopy micrographs also points the difference in the graphene oxide decoration with gold due to the variation of temperature and extract used in the treatment. The gold decoration procedure employed is a one-step marine nanotechnology method that could be improved and is performed at low temperature in less than an hour. The activity schedule we are in, we have almost fulfilled all the objectives. We have made the predoctoral exam, we have sent the publication, but we are waiting that it gets approved, and we are in the thesis writing process also. Acknowledgement to the project that they are helping us to make possible this work, and some references that we are using in this research project. Thanks.